In section 2.8, we will be solving linear inequalities. So far, we've been solving equations, and equations, remember, are just statements that say that one expression is equal to another expression. So you have two sides of an equation, and there's an equal sign in between. But when you have inequalities, you don't have an equal sign. You have less than, greater than, less than or equal to, or greater than or equal to as the sign in the problem. So what we're going to do is solve linear inequalities and graph them and learn how to use something called interval notation. So in this diagram, you see a table here that shows you a list of equations and a list of inequalities. Notice notice that they're just the same except for the symbol or the sign between the two expressions. For instance, x is equal to 3 is an equation, but x is less than or equal to 3 is an inequality. 5n minus 6 equals 14 is an equation. 5n minus 6 is less than 14 is an inequality. 12 equals 7 minus 3y is an equation. 12 is greater than or equal to 7 minus 3y is an inequality. X over 4 minus 6 equals 1 is an equation. X over 4 minus 6 is greater than 1 is an inequality. A linear inequality is similar to a linear equation, except that the equality symbol is replaced with an inequality symbol. That's the only difference in their look. Here is a definition of what a linear equality is. It's a linear equality in one variable is an inequality that can be written in the form ax plus b is less than c or greater than c, or less than or equal to c, or greater than or equal to c, where a, b, and c are real numbers and a is not 0. When you're working with inequalities, is something you have to remember. Now, let's say we solve an equation that is, and we come up with an answer of x equals 5. Well, that is a solution to whatever the equation was. Okay, so your equation could have been some long extended equation, and you solved it and found out that your answer x is equal to 5. Well, 5 is only one number, and that means that only that one number is a solution to that equation. No other number would fit. But what if I'm working an inequality and I get x is less than 5? I solve an inequality and I get x is less than 5. Well, let me ask you this. How many numbers are there less than 5? Think about a number line and tell me, how many numbers are less than 5? Please don't say 5 numbers are less than 5. Think about the whole number line. Does the number line have a beginning? Does it have an end? So how many numbers are there that are less than 5? Can you count them all? Think about a number line. You can't count them all, because as long as it's less than 5, it's a solution to that inequality. So the thing is, we can't list all of the numbers that are less than 5. So when I say I want you to tell me the solution, be able to express to me the solution when it says x is less than 5. How many numbers is that? Well, we have a certain way of writing it In mathematics, that's called set builder notation, and it looks something like this. It has the symbol for a set, which is an open bracket, and we say, well, it's all the set of all x, and we have a vertical line, and that line is read such that x is less than 5, and we close the set by closing the brackets. So it's read the set of all x, this says, such that x is less than 5. That's one way to write it. It's called set notation, or sometimes called set builder notation. That's how you would read that. So you could read it x, the set of all x, such that x is less than 5. Another way we identify our solution when we have an inequality and we solve an inequality is called interval notation. So this is called set notation. But then we have what we're going to be using is called interval notation. And it's a way to indicate all the solutions without actually trying to write all the solutions that there are. So for this particular example, x is less than 5. How would that look on a graph? If I said to graph x is less than 5, and if let's say we have 0, 1, 2, well, no, that's some goofy numbers. Let me erase that. And let's put 0 here. 1, 2, 3, 4, 5, 6. And let's just put some numbers over here. I have -1, -2, -3. Now, if we were to graph the set of all numbers that are less than 5, how would you do that? In the old days, you would have said, okay, well, I'm going to put an open circle on 5, and I'm going to draw an arrow towards -infinity, which indicates everything less than 5. Remember, open circle means you don't include 5, but it's less than 5. Well, interval notation kind of looks like that, but we're going to graph it slightly differently. We're going to graph it, instead of using an open circle or closed circle, we're going to use a set of parentheses and a set of brackets, or brackets and parentheses, to indicate open or closed circle. Watch what I mean. 3, 2, 1, 0, -1, -2, -3. For interval notation, we're going to say, well, does my solution include 5? No, because it's less than 5. Well, I'm going to put a parentheses on 5, facing the curvature, facing the direction that my arrow is going to go, to the left, because it's everything less than 5. That's the only difference. Instead of the open circle, we're going to use a parentheses. Now, if the problem was x is less than or equal to 5, we would have used a bracket. Okay, so let's try to see what we can do here. I'm going to pause and insert another slide, and I'll be right back. Okay, so keep in mind that on the number line, negative infinity is a direction. It's not a number. Infinity or positive infinity is a direction. It's not a number. You never reach infinity on the number line. You never get there because it's not a number. You never get to negative infinity. So numbers go on and on and on and on in the negative direction toward negative infinity, and they go on and on in the positive direction towards positive infinity. So what happens when we approach infinity, we never indicate infinity with a bracket. Remember, brackets are used when you have an equal sign. For instance, brackets are used when you have an equal sign in the inequality, like the picture on the right here. Like here, we have x is less than or equal to -7. That equal sign means you have to include -7, and that's why we have a bracket right here, because we're including -7. In old days, you would have used a closed circle. Okay? But negative infinity is the direction that this arrow is going. It's going to negative infinity because it's every number that's less than -7 or equal to -7. Okay, so we approach infinity on negative infinity on the left or positive infinity on the right. We use brackets when there is an equal sign attached to the inequality sign. We use parentheses when there is just the plain inequality sign. You'll see a little bit more and understand more as we move along. So let's see. Here's an example. Let's graph x is greater than -3. And we're going to write the solutions in interval notation. Sometimes it's easier if you graph them first. Graph it first, and then you can see what symbols to use for the interval notation. Interval notation. So let's graph. We want a number line. Remember, a number line has to have arrows at the end. And let's make us a -3 anywhere we want to. So if this is -3, that means this is -2, this is -1, and this is 0. All right, so this would be -5, -4. This would be 1. This would be 2. To graph, x is greater than -3. Now remember, we want every number that's greater than -3. We can't list them all, so we have to graph it. So graphing -3, but are we including -3? Is there an equal sign? Is it greater than or equal to? No, it's just greater than. So we put a parentheses facing which way? We're going to put it with our curve. Our C, basically, it looks like a C facing to the right because that's the greater than. All of the numbers to the right are greater than -3. So we find -3, we put a parentheses on -3, and we go take our arrow to the direction of positive infinity. Now, interval notation says you want to write in a shorthand way, you want to write the solution. So the way we look at it is we're starting at -3, so we put parentheses at -3, comma, all the way, so we're going from -3 to positive infinity, and we're going to close with a parentheses because we always put parentheses on infinity. Remember, it's not a number, so you can't put a bracket on it. You never reach infinity. So this is interval notation. That is saying the solution to this inequality is every number beginning with -3, but not including -3, all the way to positive infinity. And that's how you write it in interval notation. Okay, we're going to keep doing this for all the problems. We're going to write them in interval notation, so you're going to get really good practice with doing that. But let's look at now how to solve any linear inequalities. You solve linear inequalities basically the same way that you solve linear equations. Okay, so if you have a linear inequality, with A is less than B, like here, what the addition property of inequality says is if you add C to one side, you have to add C to the other side to maintain the exact same inequality. That's just like you do when you're solving an equation. So whatever you add to one side, you add to the other side. Whatever you subtract from one side, you subtract from the other side. So let's look at some inequalities and solve them. Solve x minus 6 is greater than or equal to -11. Graph the solution set and write it in interval notation. So we got 3 things to do. We have to solve, we have to graph, and we have to write in interval notation. So first let's solve. We have x minus 6 is greater than or equal to -11. You cannot graph a linear inequality until you get the x by itself. Okay, that's something you can't do. You cannot graph it until you get the x by itself. Also, you always want to get the x on the left side. Later on, I'm going to emphasize that a little bit more. You always solve to get your variable on the left side of the inequality. So let's solve. We want to get the x by itself. Well, what do? We have x minus 6, so we want to do the opposite of subtracting 6, which is add 6 to each side. Now what do we have? X is greater than or equal to -6 plus -11 plus 6 is -5. So the solution is x is greater than or equal to -5. Okay, let's graph it. You don't have to draw a long number line. We just need to indicate where our -5 is. If this is -5, this is -6, this is -4. You don't have to have 0. You just have to have the numbers around it to indicate that you understand what direction the numbers are getting bigger and getting smaller. So let's graph it. We want all x that are either greater than -5 or equal to -5. So we have to locate -5 on the number line. Do we use a bracket or a parentheses? Because of this equal sign here, we have to use a bracket, and we want everything greater than -5. So that means it's going to the right, getting bigger than -5. So we have to use a bracket on -5 like that, and we're going to have our numbers go that way with our arrow. So this means all the numbers that are greater than or equal to -5. That's the graph. In interval notation, we have a bracket on -5, and our solution goes from -5 all the way to positive infinity. But positive infinity, remember, has to have a parentheses instead of a bracket. And this is your interval notation. So we've done all 3. We've solved it, we've graphed it, and we have written it in interval notation. Next problem. Solve x plus 11 is greater than or equal to 6. Graph it and write it in interval notation. Let's solve it first. X plus 11 is greater than or equal to 6. We want to get the x by itself, so we subtract 11. This is very similar. So x is greater than or equal to -5. That's the same thing. Okay, well, it's going to end up being this exact same graph that we had earlier. X is greater than or equal to -5. You go through the same steps that we did earlier. This is, I don't know, this is by accident, or maybe I copied the problem wrong. Okay, but I'm not going to graph it again, and I'm not going to write it. I'll write it. -5 all the way to positive infinity. Next. Now, before I introduce the multiplication property of inequality, let me illustrate something. If I have a statement that 3 is less than 7, is that a true statement? Is 3 less than 7? That's true. Now, what if I take 3, that same statement, and what if I multiply 3 times 2? And 7 times 2. Is that still a true statement? What's 3 times 2? 6. Is 6 less than 7 times 2, which is 14? Is 6 less than 14? Yes, that's a true statement. So what did we do? We multiplied by a 2. We multiplied by positive 2 here. Positive 2. What happens though if we take the same 3 lose my pen? My pen went out. If we take the same 3 and multiplied 3 times, say, a -2. I'm losing my colors here. No, I don't want 3 there. I want 7 here. If I multiply 3 times a -2 and a 7 times a -2, is that still a true statement? Look at what we get. 3 times -2 is -6. Is -6 less than -14? Think about that on the number line. Is -6 less than -14? No, ma'am. No, sir. It's not. So what happens when we multiply by a negative number, what we have to do to maintain the inequality is to flip the direction of the inequality symbol to make it a true statement. Notice I've changed the direction of the inequality from less than to greater than, and now it's a true statement. It's true over here when we multiply by -2. And I did that because you need to understand with the multiplication property of inequality, it's different than the multiplication property of equality. If you multiply or divide both sides of an inequality by a positive number, multiply or divide both sides by a positive number, everything remains the same. You don't change anything with the sign, the direction of the sign. But if you multiply or divide by a negative number on both sides, then you have to change the direction of the sign for your solution. It's very, very important. It's something that people forget a lot of times, and it's very, very, very important. Okay? So if you divide or multiply both sides by a negative number, it's only division or multiplication, you have to change the direction of the sign. let's look at these inequalities and see if we can solve them. Solve negative 3x is less than or equal to 12. Okay, we have to use the multiplication property of inequality here because we have negative 3x is less than or equal to 12. What do we have to do to get the x by itself? We have to divide by negative 3. Divide by negative 3 on each side. Immediately, you should go in and change the direction of your sign before you forget, because you just divided by a negative number. Okay? So I told you, if you divide by a negative or multiply both sides by a negative, you have to change the direction of the sign. Now, this is only for inequalities. Okay? So we've just solved it. Now let's graph it. I need negative 4 on here, so I'm going to put, say, negative 4, negative 3 here, negative 5. Okay, 2, 1, 0 is here. Okay, so x is greater than or equal to negative 4. That equal sign there means we have to include negative 4. So we're going to put a bracket on negative 4. And we're going to highlight the area, the positive direction toward positive infinity. So that's the graph. Now in interval notation, we have a bracket on negative 4 going all the way to positive infinity and parentheses. So every x that's greater than negative 4 or equal to negative 4. Okay, next problem. Solve 5x is less than negative 15. Well, let's see what we have to do. 5x is less than negative 15. How do we get the x by itself? Divide by 5. Divide by 5. Notice we're not dividing by a negative here. We're dividing by a plain old positive 5, so we don't change the direction of the inequality sign. So we have x is less than, now what's negative 15 divided by 5? That's a negative 3. So now we have all x that are less than negative 3. So let's graph it. On a graph, we'll have, say, okay, negative 3. Let's find negative 3 on the graph, and let's indicate which way it's going to go. Everything less than that has to go to the left, but do we put a parentheses or a bracket on negative 3? We put a parentheses because it doesn't include the 3. And then we go to the left towards negative infinity. That's our graph. Now, with interval notation, keep in mind, I may not have mentioned this, but you always write your interval notation with your smallest numbers first. In other words, if you can always move from left to right with your numbers in the interval notation as it relates to the number line. So in this case, we're starting over here, which is negative infinity, and we're going all the way to negative 3. We're stopping at negative 3. So you have to be mindful how you write it. Negative infinity all the way to negative 3. This is where it ends at negative 3. But it doesn't include negative 3, so we put a parentheses. And you never include infinity, so you put a parentheses on infinity. So the solution set goes from negative infinity to negative 3. Okay? Now, look at this slide. There's a lot going on, but I did this on purpose. To solve linear inequalities in one variable. Step 1. Just like solving equations, clear the inequality of fractions by multiplying both sides by the LCD. Number 2, remove any grouping symbols such as parentheses by using the distributive property. 3, simplify each side of the inequality by combining like terms. Number 4, write the inequality with variable terms on one side and numbers on the other side by using the addition property. Now, it says write the variable on one side. I say always write the variable on the left side when you're solving an inequality. I put a big hint down here in pink. Put your variable on the left side. It makes solving and graphing a lot less confusing if you put it on the left side. Trust me, if you put your variable on the right side, you're going to mess up the graph. So always solve to get your x on the left. Okay? Get the variable alone by using the multiplication property. That's step 5. Okay? And don't forget, if you multiply or divide both sides by a negative number, the direction of the inequality symbol must be reversed. Let's solve. Notice I put the hint on all of these problems. Solve to get your variable on the left. Now we're going to go through through the steps to solve these equations. All right, these inequalities, I'm sorry. Negative 3x plus 11 is less than or equal to negative 13. Graph the solution set and write it in interval notation. Let's go. Negative 3x plus 11 is less than or equal to negative 13. We want to get the x on the left-hand side, so we have to subtract 11 from both sides. So we're left with negative 3x is less than or equal to negative what? 24. Now we have to get the x by itself by dividing by what? Negative 3. Now be careful. We just divided by a negative number. So dividing by a negative number means your direction of your inequality must change. Do it immediately or you will forget. So what we have left is x is greater than or equal to positive 8. Okay, so we solved it. Now let's graph it and write it in interval notation. So the graph, we need to indicate positive 8. If this is 6, 7, 8 right here on our number line, notice we don't have to have 0. We just have to have numbers that are around the other number. Okay, x is greater than or equal to 8. Greater than or equal to, is that a bracket or parentheses on 8? That's a bracket because it says equal to, greater than or equal to, and everything greater is going to the right all the way to infinity. So our interval notation goes from 8 with a bracket on it all the way to infinity with a parentheses on it. So we've solved it, we've graphed it, and we've written it in interval notation. And we got our x on the left side. Here's another one. 5x plus 3 is greater than or equal to 4x plus 3. Let's solve. 5x plus 3 is greater than or equal to 4x plus 3. Okay, I want to get the x's on the left side. So I'm going to subtract 4x from each side. 5x on the left minus 4x gives me x. Bring down the plus 3. It's greater than or equal to 3. That doesn't look like a 3. Greater than or equal to 3. So what do? Get the x by itself, subtract 3. Subtract 3 on this side. Now don't get it twisted. Just do what the problem states to do. Subtract the 3. So we're left with x is greater than or equal to what? What's 3 minus 3? 3 minus 3 is 0. 0 is a number. So when we solve this equation, this inequality, we get x is every number that's greater than or equal to 0. So we can graph that. On a number line, we have, say, 0 here, 1 here, -1 here. So we want every x that's greater than 0 or equal to 0. So what do we put, a bracket or a parentheses on 0? A bracket facing the right, because we want everything that's greater than 0. All right, so the bracket, 0, comma, infinity, parentheses. That's the interval notation. We're going from 0 all the way to infinity, including 0. Okay, once again, we want to get the x on the left side. So let's solve. -6x minus 3 is greater than -4 times the quantity x plus 1. Well, first we need to simplify the right side by distributing. -4 times x is -4x. -4 times 1 is -4. Now we want to get the x's on the left side. So let's add 4x to each side. So what do we get? -6x plus 4x is -2x. Bring down to -3. And on the right side, we have -4. Okay, now we want to get the x alone. Start working to get the x alone. So let's add 3 to each side. And that gives us -2 is great. I'm sorry, -2x is greater than -4 plus 3 is -1. Okay, so we need to, so let's divide each side by what? I want to get the x alone, so the goal is to divide both sides by -2. What happens when you divide by a negative number? The direction of the inequality changes, so you write that, and then you have x is less than, well, -1 divided by -2 is +1/2. Okay, so we want all x's that are less than 1/2. Now let's graph it. If this is 0, and let's say this is 1, and this is 2, and this is -1, then 1/2 would be in between 0 and 1. Okay, we're looking for 1/2, which is between 0 and 1, but we want all the x's that are less than that. So it's going to the left, to the smaller numbers. I forgot to put an arrow on the end of my number line there. So let's go. 1/2 is here. Now, is it a bracket or is it a parentheses? It's going to be a parentheses because there is no equal sign underneath this less than sign. It's going to be a parentheses, and the arrow is going to go to infinity, -infinity. Okay, so in interval notation, remember we start with the smallest number, which is -infinity, which is not really a number, but -infinity all the way to 1/2 and parentheses. That's the interval notation. I keep putting the hint, always solve to get your variable on the left. We want the variable on the left. So let's go. We have, I'm going to simplify it as I go. 3 times x plus 5. So we get 3x plus 15 minus 1 is greater than or equal to 5x minus 5 plus 7. Okay, I distributed on the left, distributed on the right. Now I have to combine like terms on both sides. So we have 3x plus 15 minus 1 is 14. It's greater than or equal to 5x minus 5 plus 7 is 5x plus 2. Negative 5 plus 7 is 2. So I want to get all my x's on the left hand side. So let's subtract negative 5x, negative 5x, so we have negative 2x plus 14 is greater than or equal to positive 2. All right, so the x is on the left. Let's get the constants on the right. Minus 14 on each side to subtract 14. So we get negative 2x is greater than or equal to negative 12. Then we divide both sides by what? Negative 2. And when we divide by a negative number, what do? Change the direction of the sign immediately before we do anything else, because we will forget. So that simplifies to x is less than or equal to positive 6. Okay, that's the solution. Now we have to graph it. We want 6, so I can put 5 here, 6 here, 7 here. That's all I really need. But I want every x that's less than 6 or equal to 6. So on 6, do we put a bracket or a brace or a parentheses? Bracket. And we go in this direction because we want everything that's less than 6. Okay? So interval notation now has to go from what? We're starting with what? Negative infinity all the way to 6. Now, are we including 6 with a bracket or not including 6 with the parentheses? We are including it with the bracket. And if you graph it first, it kind of gives you a hint. It's easier to graph it first and then put it in interval notation. So we did all 3. Now we're going to look at something called compound inequalities. A compound inequality has 2 inequality symbols. And it looks something like this, where we have 3, then we have this less than sign, and we have a variable, and we have less than 5. Now the way I read this as x is greater than 3. Look at that. Look at the way I'm writing it. Look where x is as it relates in relation to 3. If 3 is less than x, that means x is greater than 3. Also, x is less than 5. So one way to read this is x is greater than 3. Oh, shoot. And x is less than 5. I like to start reading in the middle. X is what? Greater than 3, but it's less than 5. So in other words, what that means is we're looking for all the solutions, all the x values that are between 3 and 5. Imagine a number line. If this is 3, and this is 5, the solution to this inequality, compound inequality, would be all of the x values that are between 3 and 5 but not including 3 and 5 because there's no equal sign on them. So we would put parentheses on 3 and 5, and we would shade in all of the values in between there. So every number in this graph where we have it in pink here is a solution. It's greater than 3 and less than 5. Every single number, all these little numbers inside of here, these little bitty numbers, okay? All of those are greater than 3 and less than 5. Whenever you see a compound inequality, that's what your graph is going to look like. It's going to look like it's going to have a beginning and an end. Okay, now let's graph this one. Graph negative x is greater than or equal to -2, and x is less than 0. And write it in interval notation. X is greater than or equal to -2, and x is less than 0. Let's graph it. This is 0. Let me make them a little bigger. Let's make this 1, -1, and let's make this -2. So we want all x's that are greater than or equal to -2. Greater than or equal to -2. So that means we got to start here with a bracket. And we're going to the right because that's greater than -2. But we want it less than 0. Now that one, because it doesn't have an equal sign under here, that one has to be a parentheses on 0. And we want to highlight all the numbers in between there. So every number in between here is a solution because every number between here is either greater than -2 or less than 0. Okay? Pick a number inside of there and ask yourself, is it true? Pick a number like -1. Pick -1 and plug it in for x. Is -1 greater than -2? Yes, it is. Is -1 less equal to -2? No, but it's greater than, so that satisfies this portion of the inequality. Okay, x, if you choose -1, -1 is greater than -2. Okay, is -1, if we choose -1, less than 0? Yes, it is. So it satisfies this portion of the inequality. So -1 satisfies that. But not just -1, all the numbers that are highlighted in here, all the numbers we can't even name, will satisfy that inequality. Now let's write it in interval notation. You can copy that from your graph. It would be a bracket on -2 all the way to 0 with a parentheses, and that's the interval notation. Okay? When solving compound inequalities, isolate the variable by performing the same operation on all three parts of the inequality: the left, the middle, and the right. What are they saying? Look here at this particular inequality. Look at that. You have an inequality symbol there and an inequality symbol there. So your inequality is a compound inequality. It has three parts. It has the left, the middle, and the right. So when you solve a compound inequality like this, you have to perform the same operation on all three parts. So in other words, you still want to get the x by itself, but whatever you do to that middle part with the x in it, you have to do it to all three parts. So let's look at it and see what we would do. Look at the middle part to see what you want to do to get the the x by itself. Look at this. So it's 5x plus 1. What we want to do is subtract 1. But if we subtract 1 there, we have to subtract 1 here and here. You have to subtract it all 3 places. Okay, now take your time and be careful. Negative 24 minus 1 is negative 25. The symbol stays the same, and we have 5x. And this symbol stays the same, and we have 6 minus 1, which is 5. So the x is almost by itself. Now what do we have to do to get the x by itself? Divide by 5, all 3 places. Okay, did we divide by negative 5 or did we divide by positive 5? Because if we divided by negative 5, we would have to change the direction of the symbols. But we didn't divide by negative, so we just keep the symbols the same. But negative 25 divided by 5 is negative 5. We keep the less than sign. We have an x, and we have less than or equal to, and then we have 1. So we want every x that's greater than negative 5 and less than or equal to positive 1. So in other words, your endpoints are negative 5 and positive 1. So you know that on your graph, your endpoints on this particular graph are negative 5, 3, 2, 1, 0, and this is positive 1. So if we have the endpoints are 1 and negative 5, we have to figure out what symbol we put on the 1 and what symbol we put on the negative 5. Well, on negative 5 we put a parentheses. But on 1, we put a bracket because it has the equal sign on it. Okay? And our x's, all the solutions fall in between here. So every number between here is a solution to that. Pick a number and stick it in the original equation, and you'll see that all of these numbers, including 1, but not including negative 5, will be a solution to that inequality. So the interval notation is easy to write. We're starting at negative 5, but not including it. We're copying this right here, going all the way to positive 1, but we're including positive 1. So we're copying that right there. And that's interval notation. Let's do one last inequality. Now, we have negative 4 is less than or equal to 2x. Well, let me spread it out some. I should probably spread it out some. Negative 4 is less than or equal to 2x over 5 minus 1, which is less than 0. Now, remember what the step said. The step said if you have fractions, get rid of the fractions by multiplying everything in the whole inequality by the LCD. Well, we only have one fraction, so we need to multiply every single term in the whole inequality by 5. All of this times 5, and this times 5. Everything times 5. And what do we get? Well, let's simplify it. We get 5 times negative 4 is negative 20. We keep the symbols the same. Now, what happens when we multiply 5 times this? Well, the 5's cancel, and we're left with 2x. Now, what happens when we multiply 5 times this? We get minus 5. Okay? Then what happens when we multiply 5 times 0? It's still 0. Okay, so we have a simpler inequality to solve. Now we go to our next step, which is to start isolating the x. So let's add 5 here, add 5 here, add 5 here, 3 places. And we simplified. Negative 20 plus 5 is negative 15. Keep the symbols the same. Then we have 2x, 5's cancel, and then we have 0 plus 5, which is 5. Now, we have to divide everything by what? To get the x by itself, we divide everything by 2. So our solution will be negative 15 over 2. We have that, and we have our x by itself, and we have 5 halves. Okay? Now, your solutions can include fractions in there. You know, if you get fractions, don't get tripped up. It's the same thing. Fractions are numbers too. It's just a little bit more challenging to graph it, but let's think about where is negative 15 over 2. If you had to figure out negative 15 over 2, what is that? 7.5? Yes, negative 7.5. So let's just get us some numbers here. If this is 0, and let's say this is 5, and this is 10, this is, I'm sorry, negative 5, negative 10, this is 5 and 10. You can label a number line any way you want to, as long as you label it, okay? You can skip numbers, you can, you can do it however you want. Let's see. So negative 15 over 2 is negative 7.5. So that's somewhere around here. 5 halves is the same as 2 1/2, so that's roughly about here. Okay, so what do we want on those? Do we want brackets, parentheses, or what? We want a bracket on negative 7.5, and we want a parentheses on 5 halves. Okay, so, and then we want to highlight everything in between. So in interval notation, it will look like this: a bracket, negative 15 over 2, all the way to 5 over 2, and then parentheses. And you've just solved multiple linear inequalities. Go back, watch the video some more, work some problems on your own, or watch the video that came with your My Math Lab with the author. I'll see you in class.